allow us to walk you through IsaMillᵶ maintenance. Thorough routine checks should be carried out by operational and maintenance staff. These routines are divided into daily, weekly, monthly and annual routines. Various IsaMillᵶ pre-start and post-maintenance routines are included. Before most inspections can take place, the IsaMillᵶ will go through an automated shutdown procedure and must be locked out prior to opening. There are minor and major plant maintenance routines in place, and there are individual procedures for the removal, installation and adjustment of IsaMillᵶ parts. Personal protective equipment must be used. These include the following: a hard hat, safety glasses, earplugs, gloves, reflective vests and safety shoes. Some sites may require additional safety equipment. It is safe to conduct maintenance on the IsaMillᵶ once it has been confirmed that all the lockout devices are in place and functional. The correct hoisting equipment, lifting devices and vehicles should be used during crane operations. Routine checks are divided into daily routines, weekly routines, monthly routines and routines that are to be performed annually. Daily routines should be carried out when the mill is in operation. These checks should be undertaken by the operations and maintenance personnel. Routines that are to be followed on a daily basis include the following: check the mill main shaft bearing temperature and vibrations for abnormalities. Check the gland seal water pressure, water flow and flushing water flow for abnormalities. Check the equipment for leaks or abnormal noises. Check the LRS electrolyte tank level for abnormalities. Check the motor oil lubrication system unit reservoir level and temperature. Check the gearbox and cooler unit temperature, and finally, check the gearbox and mill bearing filter differential pressure and clean the filter if necessary. Check the general housekeeping in the area and tidy up any problems. Check Vogel grease unit, that the grease vessel has enough grease, and top up as required. Check the Vogel grease unit touchpad screen for fault alerts. Check that the pulse detector light is illuminated. Check the relief valve for grease leaks. To refill the grease unit vessel, a grease gun is supplied. The following routines must be executed once a week. Check the Vogel auto greasing unit storage vessel for correct operation and vessel level, as well as the auto greasers when fitted. Check the motor, mill and gearbox oil lubrication system filters and clean if necessary. Check the relief valve locks for unauthorized tampering. The following routines must be executed on a monthly basis. Check the oil level and the filter in the mill cylinder hydraulic power pack unit. Check the filter in the gearbox and mill bearing oil lubrication systems and clean if necessary. Clean the mill gearbox breathers and the gearbox filter every 3 months. Check the LRS tank electrolyte level. The hydraulic power pack is a device designed for the opening and closing of the IsaMillᵶ shell. It can also be used to move the non-drive end assembly. Prior to starting the hydraulic power pack, the following routines are required. Ensure that the electrical cabinet is securely closed. Check the hand control and the control cable for any damage, and check the main power cable and the main power plug for any damage. Check that the oil tank level is within the limits on the gauge. Check both oil connection nozzles for damage and clean if necessary. Check the machine for any leaks. The IsaMillᵶ needs to be shut down for the maintenance inspections. The stop sequence is automated. The IsaMillᵶ shutdown sequence is initiated and automated by the control room operator. The IsaMillᵶ must be flushed out before it can be disassembled for inspection. The flushing sequence must be allowed to continue for a period of approximately 15 to 20 minutes until the IsaMillᵶ is drained of media. Before we continue with plant maintenance routines, we would like to emphasize the following. It is extremely important to take and record good measurements of the IsaMillᵀ components in order to make future maintenance decisions and predictions. Xstrata Technology have developed an IsaMillᵀ information system known as IMUS to capture the operational and maintenance information. IMUS also provides some predictive tools to assist with decision making. All site-specific requirements of inductions, isolations, toolbox talks and risk assessments must be adhered to. Once the aforementioned shutdown routines are completed, the IsaMillᵀ can be disassembled for maintenance inspection. IsaMillᵀ disassembly procedures include the following steps. Obtain an IMUS maintenance record sheet. Check the DCS trends for the gland water flow and pressure. The gland follower position should also be checked on the mill. If the flow is high, the pressure will be low. If the gland water flow is high and cannot be adjusted correctly, the gland packing and wear sleeves should be checked and replaced if necessary. Be sure to record the mill motor run hours. Check with operations that the mill has been through the correct flushing cycle. Isolate and lock out the IsaMillᵀ motor and the feed pump motor, as well as the gland seal water and the gland flushing water supplies. Activate the mill scuttle valve and empty the remaining contents, if any, into the media hopper. Disconnect the mill feed line, flush water line, valve air line and instrument connections. Unbolt the mill slurry feed pipe and swing or lift the pipeline assembly away. Move the hydraulic power pack to the mill adjacent to the quick-release hydraulic connections. Connect the hydraulic power pack hoses to the mill as has been discussed. Remove the drive end flange bolts. Ensure that all personnel stand clear of the IsaMillᵀ shell. Once everyone is clear of the area, it is safe to open up the IsaMillᵀ shell. Once the shell is open, install the safety pin. Pull the shell away from drive end flange with the hydraulic power pack and give the mill internals a thorough hosing if required. Inspect the mill internal components and record component dimensions on the routine maintenance inspection sheet. Record the measurements of the shell liner as detailed on the IMUS sheet. Measure and record the minimum rubber thicknesses of the flange liners. Inspect the rotor and discharge ring for wear. If the shell liner wear dictates, rotate or replace the shell liner as required. Measure grinding disc dimensions and record by marking dimensions on the discs and in the log sheet. Replace discs that are worn beyond the point of reuse. The disc hubs must be removed from any discs that are replaced. It is good practice to prepare new discs with the removed hubs before the next maintenance opportunity. Rotate the position of worn discs that can be reused. For example, disc number X will be replaced, disc number Y will be reinstalled and in position Z. Take a full photographic record of all wear components. Close the IsaMillᵀ shell using the hydraulic power pack. Uncouple the hydraulic cylinders from the shell and retract the cylinders fully. Store the power pack as per the procedure mentioned earlier. Reconnect the flushing water line. Lift the inlet pipe assembly into place and bolt it to the mill. Connect the air line and instrument cables. Finally, remove the isolations from the various surfaces. The inspection involves establishing checks and measurements of all IsaMillᵀ parts to interpret the wear and functionality of all the individual parts. Individual procedures for the removal, installation and adjustment of IsaMillᵀ parts are to be described now. This is the mill maintenance work that follows the initial inspection. The following steps are required for the removal and installation of discs. Remove the polyurethane plugs and the shaft end cap faceplate, support the plate and remove the securing bolts. Remove the faceplate from the sharp end cap. Remove the 3 rubber plugs on the side of the shaft end cap and loosen the locking grub screws, which secure the heads of the shaft end cap securing bolts. Remove the 3 shaft end cap securing bolts. Support the shaft end cap with the lifting clamp and remove it from the shaft. Rotate the mill shaft so that the drive keys are at the top and bottom to aid removal of the components. The disc can now be slid along to the end of the shaft and removed. If the disc can be reused, put it aside. Rig the shaft spacer with a soft sling and remove it from the shaft. Remove the remaining discs and shaft spacers using the same method. New discs can now be installed. The installation process is as follows. Clean all components that are to be reused in the mill as well as the shaft. Grease the shaft with a light grade of grease or heavy oil, as this limits corrosion. Ensure that all shaft spacer O-rings are in place. Lift a disc, complete with hub, so that the keyways are located top and bottom. Lift the disc onto the end of the shaft, then push it to the drive end of the shaft, followed by a disc spacer. Reassemble the remaining discs and spacers onto the shaft. Install the shaft end cap and tighten the bolts evenly until all 3 are firm. Using a torque wrench at the final tightening of the bolts, torque the bolts so that a flat face of each bolt is square to the locking grub screws. Then tighten the grub screws and insert the protection plugs. To finish off, install the sharp end cap faceplate. If, when measuring the shell liner, the wear is found to be too great in some areas, rotate the liner to move the wear points to a less wearing position or replace the shell. We will now demonstrate the rebuilding of a disc. Remove a worn disc from its storage rack, clean the disc and lay it down with the bolt protection plugs facing upwards. Remove the bolt protection plugs from the old disc. Remove the disc retaining bolts and discard them. Leave one bolt in to prevent the hub and disc separating during the next step. Turn the disc over and lay it down on a suitable raised surface, remove last bolt and then separate the hub from the disc. The hub must be cleaned and the hub and disc inward faces lubricated. Lift the hub onto the new disc, install the new retaining bolts and tighten the bolts using a torque wrench. Apply silicone in each of the holes and install the bolt protection plugs. The disc assembly is now complete and can be placed back onto the storage rack. The rotor is removed from the shaft in the same manner as the discs. Once removed from the shaft, the rotor can be placed on a floor area to allow the rotor ring to be removed, so that the rotor fingers can be rotated or replaced. After the rotor has been removed from the shaft, the discharge screen area can be accessed. To remove the discharge ring, the displacement body end plate liner must first be removed. If this liner is to be replaced, the stainless steel displacement body end plate must be removed so that it can be fitted to the new liner. There is a special tool supplied with the mill to assist with the lifting, removal and installation of the displacement body end plate liners. The discharge ring and discharge ring wear ring can now be removed from the displacement body. With the discharge ring removed, it is possible to visually inspect the displacement body for wear. All of these components are installed back onto the mill in the reverse order of being removed. Either of the flange liners can be accessed by separating the shell from the flanges. There are some threaded rods supplied as special tools with the IsaMillᵀ. To remove the flange liners, a couple of the securing screws need to be removed from the top of the flange and be replaced with the threaded rods. With these rods in place, the remaining securing screws can be removed so that the flange liner can be slid away from the flange. With a gap between the flange and the flange liner, the liner can be supported by a crane and the threaded rods removed. The new liner is installed in the reverse order. Moving on to the gland adjustment procedures and gland packing adjustment procedures will follow. Due to the close proximity of the gland housing to the non-drive end bearing, gland servicing is generally carried out from the wet end during a normal routine mill service. It is possible, however, to install 3 rows of new packing from outside of the mill. But as a general rule, if the gland requires rebuilding, it is best to strip the mill and rebuild the gland from the wet end. The gland area can be accessed from the wet end by removing the rotor and discharge ring as described earlier. If replacing the gland packing, the condition of the gland wear sleeves should be assessed and replaced as necessary. First, we will take a look at the gland packing adjustment procedure. In order to adjust the packing rings once the mill is operating, tighten the gland follower bolts evenly from either side of the mill. Tighten the nuts until the gland water flow is running at the correct flow and check the gland drain temperature. Avoid over-tightening the gland and causing the temperature to rise too high. As a guide, the gland follower should only be adjusted a maximum of 2 mm before being left to settle for 1 hour to see what the new gland water flow is. If further adjustment is required, it should only be made at the rate of 2 mm every hour. Any gland adjustment must be evenly made on all sides of the gland. The following shell liner procedures should be used: measuring guidelines, removal and rotation procedures, and installation procedures. With the shell open at the drive end, start from the drive end and measure and mark 17 predetermined shell liner measurement positions along the length of the shell liner at 4 different clock positions. Using the spike measuring tool, measure the rubber thickness at each of the measurement positions. Take readings at the same position each time in periodic sessions to build up a wear profile. A used shell liner should be removed or rotated, depending on its condition. This procedure requires the mill shell open at both ends. Remove the shell half bolts, lift off the top shell half and store it away from the work area. Lift out the used liner using the liner lifting device. Rotate or discard the liner as determined by the wear. Clean the inner surfaces of the 2 shell halves. Once these procedures have been completed, we can continue with installation. Lift up the liner using the liner lifting device and fit the safety chain between the shoes of the lifting device. Lower the liner into the lower half of the shell, making sure that it is centered. Rubber filler strips can be glued to the top of the shell liner to eliminate any vibrations between the shell and shell liner. Install the shell top half. The liner should be a neat fit in the shell with a millimeter gap between the shell halves. Bolt the 2 halves of the shell together. Pull the shell assembly back to the mill with a hydraulic power pack. Ensure that the drive end flange O-rings are in place. Then install and secure the flange bolts. The guards around the couplings need to be removed and cleaned at each maintenance. The coupling should be visually inspected for any wear or defects. The lubrication level in the Zapix gear coupling should be checked. Reinstall the guards. The Labyrinth greasing unit is a Vogel device. The unit supplies grease to the 4mm main shaft bearing Labyrinth seals to prevent dust and water from entering the bearings. The greasing unit pump starts when the mill main drive motor is energized. It goes through a full cycle and then operates to the frequency and duration set in the control philosophy. Special service tools are supplied with the IsaMillᵀᴹ plant. As mentioned earlier, it is very important to use the correct equipment when performing specific tasks. The following special service tools are supplied with the mill to aid in handling the components. The hydraulic power pack, the shaft support jacks, shell liner lifting tool, lantern ring extraction tool, disc hub lifting plate, disc kidney gauge, displacement body and plate liner lifting tool. Xstrata Technology have developed an IsaMillᵀ information system known as IMUS to capture the operational and maintenance information associated with the use of IsaMillᵀs. Production parameters can be captured in 10-minute intervals. Maintenance measurements can be recorded, and a history of what parts were replaced on what dates is also recorded. IMUS also provides some predictive tools to assist with decision-making. These functions use statistical analysis of the history to predict the normal component wear and component life. IMUS has some standard reports that allow maintenance reporting to be produced at the press of a button, once the information has been captured in the system. The evaluation of the IMUS history allows improvements between operations and different ore types to be identified. Xstrata Technology have often been able to identify operational issues through the information contained within the IMUS database before the sites identify there is a problem. We at Xstrata Technology are happy to have shared our knowledge and practical understanding of IsaMillᵀ maintenance procedures with you. Thank you for lending us your attention.